The last section, uh, I would like to invite Scott Martins, that is the PI for Go Amazons, to talk about the Go Amazons.
Thank you very much, Luis, for inviting me to the meeting, which I have really enjoyed, and an opportunity to share with you all another field campaign that's coming up that might also catch your interests. Okay, so Go Amazon, Observations and Modeling of the Green Ocean Amazon, which we call Green Ocean Amazon, Go Amazon. It's an honor to have here Williams, because we always cite his paper as the meaning of the Green Ocean, which a lot of folks confuse and think it has something to do with the trees. And I say, no, it's all about the lightning. That's all it makes for an interesting story. Okay, so Go Amazon is organized around 4 thematic areas. Cloud life cycle, which I think involves most of the folks in this room. Aerosol life cycle, carbon life cycle, and their interactions. Cloud, aerosol, precipitation, interactions. So as PI, I have a hat to tell you broadly about the program, and in terms of my own personal expertise, it's in the aerosol life cycle area. Okay. And I'm going to adjust my 30-minute talk to a 20-minute talk, so I'll focus on the things that are quite relevant. I think this audience is educated with regard to, well, I know this audience is educated with regard to a lot of the introductory material here. In terms of Manaus, what you're looking at here is the pollution outflow, 2 million people. You're looking at an image of the NO2. One concept of Go Amazon is to be downwind of this pollution. You see it's an excellent opportunity. I make some analogies of Manaus to Hawaii, where if Manaus is in the green ocean, Hawaii is in the blue ocean. The point being that Hawaii, everything comes in by boat, goes out by boat. Hawaii uses a high sulfur diesel for its electricity. So far you're seeing a lot of analogies here to Manaus. There are no other main pollution sources around Hawaii. Same with Manaus. Of course, there are a limit to the analogies between the green ocean and the blue ocean. But Manaus represents a highly isolated area, and so that if we are downwind of it and getting the pollution plume, we can really assess the effects of pollution on a number of interesting metrics that cross-cut into aerosol life cycle, cloud life cycle. Other parts of the world, when you get pollution, you can't quite be sure of where it's come from, how aged it is, so on and so forth. When we're hit by large episodes of pollution, we really know where it's come from, how long it's been in the atmosphere, so on and so forth. And looking at that in a tropical context where a lot of the details are different from kind of the temperate zones that have been studied intensively before. So folks know of Manaus as having a lot of diesel use, a lot of black carbon. The electricity comes from high sulfur diesel, a lot of sulfuric acid downwind, a lot of ozone, a lot of particles downwind. These are things that you all know. Okay, so here is some information. The main instrumented site that I'll talk about today is north of Manacapuru on a private farmer's site. Most of the Department of Energy equipment will be deployed there. And what we're looking at a train, of course, with the steady trade winds from the 300-meter tower of the German-Brazilian collaboration that's being built. It's upwind, fresh, coming through to a site on IMPA, an urban site, T1. Across the river, an instrumented site in Cacapoeira, Iranduba, just across, so it gets the fresh pollution, T2, and then depending on prevailing winds, 2 to 6 hours of transit time to the Manacapuru site. You know the trade winds. We had a couple of very nice presentations on that, so you know the reliability. The estimate is we'll be in the pollution plume half the time, out of the pollution plume half the time to get the contrasting polluted and clean conditions towards the number of endpoints. Whether it turns out to be 70-30 split or 30-70 split remains to be defined. Other sites, there's been discussion to put Shuva instrumentation to the north to start to try to put together a triangle of complementary sites. And of course, the triangle, you get a lot of constraints on energy balance, and then ecosystem research at the site ZF of 2. Right, so that's a layout of the sites. This is in a little bit more detail, again with the trade winds and Manakaparu here, and we are here with the main DOE site that I'll talk about today. Just moving right along. This is giving you a sense of the plume that goes with the trade winds, the site being here. So this was one specific aircraft campaign that was carried out, was published in 2010, carried out, I think, 2001 maybe. And these are transects. These just give you an idea of the pollution. So as you go downwind along those transects, you can see first of all, the pollution plume has very sharp edges, very little divergence along the pollution plume. You see the buildup of the ozone. As the ozone builds up, you see the NO reacting. You see carbon monoxide. So it's a very well-defined plume. If you collect particles and look at them, they're close to pure sulfuric acid. When you're out of the plume in the wet season, something like 300 total particles per cubic centimeter. When you're in that plume, this instrument cut off at 10,000 particles. We know from more recent measurements it goes up to 30 to 50,000 particles. So between clean and dry, or clean and polluted conditions, by a number of metrics, you have about a 100-fold change, a 2-order of magnitude change. So a really sharp contrast, and that's a big motivation for the experiment. So as said here, we'll be downwind, and we'll be looking at the heavy pollution and the interactions of that pollution with the natural environment. And then there's a lot of fill in the blank here. I can ask you in the audience, what is the effect of pollution on? And then you fill it in here with your favorite topic. If you're a chemist, you ask, what is the effect of pollution on production of secondary organic aerosol in the atmosphere? If you're working on cloud physics, you all will fill that in with a much different set of questions like cloud brightness, temperature, or susceptibility to precipitation, or intensity of rainfall, or cloud droplet number concentrations. So the theme is quite broad. We've heard a number of the talks today related to the interactions of energy, clouds, rainfall. I'm going to go through this quickly in the interest of time. But just to remind you that we're a large umbrella with a number of questions related to the connections of ecosystem, air quality, climate, and human activities, pollution. Okay. So now to get to some more specific information, if you're thinking about involvement in the campaign that could be useful to you. The DOE portion of the campaign, the DOE has a user facility. The user facility means it has radar systems, has aerosol instrumentation, has about 9 containers of instrumentation. We and a number of the authors are in this room. Thank you very much for that. About 25 of us wrote a proposal to DOE to say, why not send your user facility to the Amazon for a year? And that was such a good idea, we wrote the proposal again and said, why not keep it there for a second year for variability? Both of those proposals were approved, and so the equipment arrives and makes measurements from the 1st of January 2014 to the 31st of December at the ground site that I showed you north of Manakaparu. Also some in the T2 site here in Duba. There are a number of complementary measurements to this, and I will tell you about them as we go through the presentation. This is really the Department of Energy portion. There's an aircraft. For the first part, we have the scientific license. For the second part, the aircraft, Carlo Longo is working on the scientific license for that. That's pending. So it would be in the wet season, February, March, and then again in September, October. Overlapping with these, we also have intensive operating periods of 8 weeks where individual investigators will bring in specialized research instrumentation that really can't be left there on a ongoing 24-month monitoring basis, but requires graduate students, postdocs. So I have 2 IOPs in 2014. We haven't thought into 2015 yet in that regard. The aircraft is a G1 aircraft, flies at something like 1,000 to 3,000 meters. Okay. This is the site. We installed a weather station December 2011. This is a site now in March 2013, so the first container is in, kind of a test of import-export, test of scientific license. It has some basic meteorological instrumentation in there. It's got some long-wave, short-wave, upwelling, downwelling, radiation measurements, MET station. Recently installed Paolo's mass spectrometer. So we're starting to get some basic climatology. We're not yet officially recording data. We're really testing a lot of things. The electricity. You get to the site. It's an all-asphalt road. To get to the site, it is private landowner, so you can't just go to the site. You have to coordinate with the project manager for, to have permissions to go to the site. But site's very accessible for an Amazon location. These is the ground site for the ARM facility, the project scientific license AMFA, ARM mobile facility in Amazonia. Consists of 7 to 9 containers. I've got a list of the equipment on the next slide here. You can also get this same list, AMF1, if you put that into Google and look for the Department of Energy. You'll find this list, so I don't think I want to take the time to go through it, but just to point out that there are a number of instruments that that overlap things that I've heard from presenters today, so that there will be a number of constraints on cloud properties, a number of constraints on energy balance. There will be scanning radar systems. One of the reasons we have it in that large field location is so that we can scan very close to the horizon, K-band, W-band. There will be contributions from Shuva with an X-band. We have a proposal in NSF for an S-pol, S-polarized, S-band with polarized radiation. Okay, now the thing about it's a user facility. This means that all of these data, in principle, have a mentor and are available on the internet in the next day. The point is that whether it's the next day or a week or two, I suppose depends on the efficiency of the mentor and problems with the instrumentation. But the point is, none of these data have an owner. These are publicly available. Anyone can take it, do a project, write a publication. That's the philosophy. There will also be a Fourier transform spectrophotometer for a number of gases. Okay, there's also an aerosol container that will provide a number of pieces of information related to air quality, particle size distribution, composition of aerosol particles, their CCN activity, gas phase instrumentation, how much sulfate do we have, how much nitrate do we have. Again, this instrumentation, to a large extent, will also be in a proposal that Paolo and Assunção have pending that would be at a T2 site. They have a lot of overlapping information. And so in this way, we'll be able to see the pollution right when it comes out of Manaus, and then after it ages for 6 months or 6 hours, 2 to 6 hours in the atmosphere, and then get a sense of processes that take place as well for particles. Okay, the G1 Yara 2014, which is the ARM aerial facility. We have outfitted this. I think the presentations might be available, and this information is also available on the Go Amazon website. So you can look through this. But I will tell you, choices in outfitting the instrumentation. Okay, so what did the scientific steering committee choose? And I think half the scientific steering committee on the Brazil side is in the room here, and the Brazil side scientific committee is a little larger than the USA side. I think the Brazil side has 6, and USA side has 5. Okay, so what did we decide on? We're highly outfitted for aerosol, gas, and cloud. We had to leave off what you would say is the radiation measurement equipment. So we will know a lot about cloud droplet size distribution, going from 400 to 50,000 microns, 10 to 300 microns, 2 to 50 microns. I know, talking with Luis and Assunção, that they're very interested in these measurements that really these types of in situ measurements. There's not a lot of data of this type for clouds in Amazonia, and so this will be a unique data set. Again, this information is available publicly on the website in principle shortly after the measurements are made. We also have a lot of chemistry capabilities. This overlaps with interests that I have, that Paulo Artacho has, that Carla Longo has, among others. Okay. We have 35 flight plans. They are with the Brazilian, or close to being with the Brazilian Air Force. This is just an example of one of the flight plans. So if the plume is running here from T1 to T3, then we'll do transects across the plume and observe the plume aging and transformations. We have other flight plans that are worked out that focus on cloud properties. And then we have other flight plans that we have a second aircraft, which I'll talk about in just a second, or propose to have a second aircraft, in which the two aircraft go together. Again, if you're interested in any of the approved flight plans, I don't know if those are on the website, but you're welcome to contact me. Again, they were thought out both with the needs of some of the flights will be dedicated to cloud processing, some will be dedicated to chemistry. A few are able to do both. Okay, just a little bit more information during the IOPs, which are in the February, March, and then in the September, October. This also brings in the German groups through ADO. The coordination there will really be interested in bringing in research level instrumentation that can't be used for a full 24 months to get at where particles come from, how they're transformed, what types of atmospheric chemistry is taking place, what's the atmospheric oxidant cycle, how is it affected by interactions with the anthropogenic plume. Just to give you a contrast, these are data that we took supported through the Science Without Borders program in July of last year. This is kind of the background particles in Amazonia, clean areas. They're centered at 100 nanometers, and this is downtown Manaus. All the soot particles kind of centered at 10 nanometers. And so again, you see, and I normalized just to compare them. The integrated concentration here is about 50,000. The integrated concentration here is about 1,000 per cubic centimeter. So you have these huge contrasts in the two regimes that we'll be examining when we get clean conditions and polluted conditions. This is wet season, dry season. These are data from Luciana Rizzo and Paulo Artacho. Just showing that in the wet season, something like 300 particles. In the dry season, something like 1,500 particles per cubic centimeter. Why is that? Is that because of more regional pollution? Is that because of less wet deposition? It's a combination of those two factors, getting at that information. And then with the 2 years, how does it vary between 2 years to try to get at some of the statistical information. S-band, this is a proposal pending with the United States National Science Foundation. Heavily involves Courtney Schumacher, Luis Machado, Assunção, probably others who are here. And we hope to get an answer in about 7 to 8 weeks, a definitive answer, so we'll know if the S-pole will go. That will include additional soundings as well. Also will include a balloon that floats with the air directly from Manaus, an instrumented balloon. Okay, so one of the key ideas, and I think this overlaps with things that Shua has in mind in cooperation. And as I said, the same, Luis Machado, for example, is very involved in both. I think a number of folks in the room are very involved in both. But an idea is to set up a triangle or even a quadrilateral to try to get constraints on energy fluxes. Okay, Acrodecon, which we'll hear more from Luis on. This is would be a German-Brazilian project that would use the Halo 5, which is high altitude, long distance, and some of those flights would be done locally to coincide with the G1. This aircraft and science is particularly interested in ice as well. Some of the instrumentation that is on there. So you can see the focus here, aerosol particles, ice, radiation, trace gases with these inlets, counterflow, has a number of capabilities to characterize ice. These are the different wing stations. with the various particle diameters. So between the Acrodecon aircraft and the Yara aircraft, we'll really be developing a brand new in situ data set. I don't know what the data availability policy is for Acrodecon. I don't know if that data is readily available. Luis can probably speak to that in his talk, or if that is first owned by a PI and then made available later. I don't know the answer to that question. Okay, Acrodecon has 4 mission types. I thought I would just highlight the one that I would myself be most familiar with, which is the aerosol processing. I think Luis will go into some of the others as well. And so the idea behind this is that particles that come in are not the same as particles that come out, both chemically and in size distribution. So how does processing through one of these large clouds change the atmospheric aerosol? And using the instruments on board to fly the G5 to sample on the outflow, and then use the G1 to sample below, start to get information in a statistical sense of how aerosol below cloud is different from processed aerosol. And by the way, those are the ones that also were apparently poor CCN and didn't participate in the formation of the cloud and rainfall, if there is rainfall. Okay, this experiment's done in the context of LBA. The Scientific Steering Committee for LBA has considered the project, approved it. One of the messages that we've gotten on the USA side in the Amazon region is to really try to build up the intellectual infrastructure. And so through Science Without Borders, we're very strongly encouraging folks in the U.S. to open up their laboratories, receive students. If you are a student and would like to have an opportunity, I hope that the mechanism can be that your advisor here identifies a counter scientist in the U.S. and then you as a student go there and act as a bridge. So we have a substantive project tied into Go Amazon. And on the Brazil side, a number of organizations involved, LBA, IMPA. IMPA is heavily involved with the ground site. IMPE is heavily involved with the aircraft. CTA, UEA, USP, SHUVA, Ciências Sem Fronteiras, FAPIAM, FAPESP. We're expecting very soon, if not yesterday, hopefully today, if not today, hopefully tomorrow, but very soon, funding announcements from FAPIAM, funding announcements from FAPESP. So these would be things that folks, if you're in the appropriate position in your career, you would apply for in order to get funding, in order to participate in Go Amazon. And there's a counter call that hopefully comes out in the USA in the next few days as well. These things always seem to linger longer than we expect. If you're interested in more information, I've got a website here where it's just a list of 20 or 30 presentations that have been given. I'll put this one up there as well. If you want some background, if you want to get on an email list and receive email from me, you can sign up for it there. And so I hope I stayed close to the 20 minutes that I was asked to do, and look forward to getting to know any of you who might get involved further in Go Amazon. Obrigado. What would you like to know? We've got this slide. Mm-hmm. Mm-hmm. Yeah, so I know what my main objectives are, so to speak, in the aerosol life cycle, and I could put up for you what we put in the kind of the objectives for the cloud life cycle. I think more interesting, I'm going to defer that to Luis, because I think he can explain better some of the things that we're interested in. But just briefly, we have a very strong contrast between the river and the land cover, and so we're interested in how that kind of scale heterogeneity of 10 kilometers, how this ties into formation of clouds and the properties. We're also very interested in possible kind of urban heat island effect on formation of clouds over Manaus, and we're also very interested in how having suddenly going from 300 particles per cubic centimeter to 50,000 particles per cubic centimeter, is this have a measurable effect on precipitation rates, on cloud brightness. I mean, certainly we expect it to, because you kind of expect from 300 to 1,000 particles per cubic centimeter, kind of a linear response, and above 1,000 maybe being saturated. But getting a serious investigation of that underway. So those are some of the aspects. I think Luis might be able to comment on it even more eloquently, so I'll pass it to him.
During the Acridicon, we have the scientific objective, so I can present that.
You'll present more. Okay.
So, other questions? Okay.